Yes, hello, I'm Trisha. I work for Gradle. I used to work for LMAX between 2008 and 2012. And then after that, I worked for JetBrains doing IntelliJ IDEA stuff. And I'm really pleased with what Ed talked about in the previous talk because it overlaps nicely with what I'm going to talk about, and also allows me to skip over some of the things that have already been mentioned. But it sets the stage nicely. So today I want to talk about, are your tests slowing you down, which ties in nicely to this idea of fast feedback and like responsive feedback. Firstly, I do want to say buy my book. It's really helpful. I have two books. One I'm going to give to LMAX because I learned a whole bunch of IntelliJ IDEA tricks as a pair programmer here at LMAX. Put them in a book. The other one will be raffled off after this talk. So there will be a QR code at the end of the presentation. I'll probably have about 3 seconds to actually like pick a winner and then give it to you before we leave, because I think we're getting kicked out at 9 o'clock. Also, sharp-eyed amongst you will have noticed I have 97 slides to get through and an hour. So there may not be time for questions. Right. The reason I'm talking about what I'm talking about today is that Gradle is trying to talk about this thing called developer productivity engineering, DPE. They say developer productivity engineering is a software development practice to maximize developer productivity and happiness. I'm much more interested in the happiness bit than the productivity bits. That's kind of where I'm coming from. It overlaps with things like platform engineering, developer experience. It's all in the same kind of space of like what things are slowing us down as developers, and therefore what can we do to make us more effective, more productive, and hopefully less miserable with our jobs. So tests make you more productive, right? That's why I'm going to talk about testing today. The reason I'm going to talk about testing is that I think tests are very valuable for fast feedback, for making sure we didn't break anything, for for making sure we did the right thing right, and that we don't break things that are already being tested. However, I think that quite a lot of people just don't really see the fast feedback part of testing, because writing tests can be a bit of a chore. I think someone over here said something about writing good tests, right? And like, even if we have tests, they can be a bit long to run and get feedback from. And then when things go wrong, how do we fix them? So I run into a lot of developers who do not agree that tests make you more productive, that in fact tests are a blocker to their productivity. So I want to have a look at what might be causing that feeling and what maybe we could do about it to improve our experience with tests. If you came to this talk to hear Trisha say it's okay to not write tests, is Beza or DJ in the back? No, that's not what I'm here to say. I am a big fan of testing. I agree with Kent Beck that testing is a way to reduce your anxiety as a developer. If you have automated tests and they go green to begin with and then keep going green as you make more changes, that makes me feel better about what I've done. That gives me the safety net to know that I haven't done anything stupid. So I'm a big fan of tests, particularly automated tests, because manual tests are definitely not quick, and it's important to have tests. So let's not talk about why we need tests, because that would take an entire presentation. I do always have caveats for my presentations, so caveats. Last time I gave a presentation in front of one of my children fell asleep. So it may not keep you awake. And it will contain product placement, because if you don't know what a developer advocate does by now, a developer advocate is paid by someone like Gradle to do thought leadership and accidentally mention products that maybe you could buy, which tie into the thought leadership. I will put Develocity on the bottom of slides, which is specifically talking about a product that Gradle has. Right, speaking of which, who knows that Gradle has, who's heard of Gradle? Thank you, good. Who knows that Gradle has 2 products? Right, because you've been to my talk before. Right, Gradle has 2 products, the build tool. Who's using build tool, the Gradle build tool? Who's using Maven? That's fine, we love you too, that's fine. Develocity is a DPE tool, which is why we're talking about DPE. Develocity is a developer productivity tool which works with Maven, Gradle, Bazel, and SPT. And it's all around the stuff that Ed was talking about in terms of measuring everything about your builds, your build times, your tests, your failures, what went wrong, your flakiness, and all those things. And it works with the modern JVM build tools, all of them, so that you can get those kinds of metrics. So that's why I'm talking about this kind of thing. And if you should happen to want to call our salespeople and buy Develocity, that would be marvelous. But if you don't, that's fine too. So, and the other caveat is there's not a lot of stuff in this talk which is brand spanking new, because this is about testing, and testing is a good thing, and we should all do testing, but nobody likes doing testing. So that's why I'm going to keep repeating why we need to do testing and what's good about it. It's just really trying to bring together a bunch of ideas. She doesn't agree with my talk. Right. Hopefully, if you're already on board with the idea of we should be doing something to make testing a better experience for our developers, there should be some stuff in this presentation that you can take home to your teams and go, let's try this. Hopefully, there's a lot of stuff, but if you just come away with one idea, that would be great. Okay, so I asked social media, let's call it Twitter because I'm not going to call it the other thing, what slows down your testing? And the majority was unreliable test results. So we're talking about flakiness and intermittency, which has already been mentioned today. Writing tests slows you down, which is a little bit worrying. Running tests locally, running tests in CI, debugging and fixing tests are all kind of like not really as important, which is kind of surprising to me because I thought that running tests is something that slows people down. Because if you've got 30,000 acceptance tests like they have here at LMAX, it does take 20 minutes to run them, and you do want to know, did my test pass? So I'm going to lump these into three categories. I'm going to address the idea of writing tests slows us down, running tests slows us down, and debugging tests slows us down. And those are the three things we're going to cover. So firstly, writing tests takes time. And my caveat here is I actually like tests and I like writing tests, so I'm not great at putting myself into the shoes of someone who is just like, oh, testing. Because like, I don't really understand how people know their code works if they don't write a test. So that's my caveat for this whole section. I do like writing tests because I want to know that second, third voice in your head, which goes, what if you've done this? And what if the user does that? Like, it's nice to have a test to show all those things. So, demo time. So let's talk about writing tests. I will do a demo of using your IDE to write your tests because I have a book to sell. So if you like my books, if you like my tips about IntelliJ IDEA, please buy my book or win it for free. So let's talk about how to use your IDE to write tests. Now I don't have my speaker notes visible here, so like I'm just going to have to guess. I've been on holiday, so I can't remember any keyboard shortcuts. We're going to use, shall we zoom that? Let's zoom that. New feature in IntelliJ IDEA, Zoom IDE. Can you read that a bit better? Yeah. Okay, so of course, Zoom itself is putting its little bar in exactly the wrong place, so I can't see it. Let's move that out of the way. Okay, yeah, from here it's fine, but I can't see it. It's right in the middle of my face. All right, so we're going to ask IntelliJ IDEA to navigate to test, which will, let's pause my screen sharing because apparently that's the same keyboard shortcut on Zoom as pause screen sharing. It's totally ruined my whole demo. Right, let's see if I'm in the right place. Will it let me do that? There we go. So create a new test for this particular class. I'm going to create a JUnit 5 test. Add it to Git, fine. I can use Command N to generate a new test method. That's great. But this is a very basic test method that will just enable IntelliJ IDEA when you're doing your code completion will always just do the bare minimum to keep everything compiling. So this is kind of what it puts as a test. Something I learned at LMAX, which some folks over there might actually recognize, is I have a live template, which I more or less inherited from Amir when he worked here. And that will give me the basic outline of the test as I want it. So it uses a display name and a method name, which begins with should. So I'm going to have, I can't remember what this test should do now. Should extract Twitter handle from tweet. And the live template will do the same thing between the display name and the method name. I have given, when, and then, because otherwise, how do I know what I'm testing, what's set up, and what's assertions? Big fan of given, when, and then. So then let's start here. So when I have I've got a user service, get Twitter handle from tweet. My tweet is going to be example input. I'm going to use IntelliJ to create this constant. I'm going to paste from the clipboard my tweet data. I am also going to, oh, I've got an extra semicolon, surround with an editor fold, which is, I'll call it data. Oh, I always do that. So then I can just fold that away. I can put whatever comment I want in here, but I can just fold away that stuff there. Then I'm going to, this is the handle, and I'm going to assert equals expected Trisha _G and handle. And I should be able to run that. And it passes, which makes me nervous. So I'm just going to see if I can make it fail first. Does it pass for the right reasons? Right. Okay. So then, so I can quite quickly use some IntelliJ features like code generation, code completion, live templates, just to generate a whole bunch of the boilerplate around writing the test. It's fairly straightforward. I hope you're all already doing a whole bunch of that stuff. So you can use your IDE to generate tests, to generate the basic boilerplate around the test, which is probably not really everything that's slowing you down, but getting the knack of using some of these shortcuts, particularly custom live templates, will help declutter your brain from the boilerplate and allow you to focus on what does this test, what is it supposed to do? What do I really expect? I also really like given, when, and then, because it really helps you think about which is the setup and what is the thing I'm actually testing. Because as soon as you've got a block of code which is more than 6 lines in a test method, it becomes quite difficult to figure out what's the real thing that I'm testing. So buy my course if you want to. There's loads of stuff in there about TDD. Right, so of course, we're in whatever year we're in right now, 2024. That's, what is it, 4 years post-COVID, let's call it. We are all talking about AI these days. So we are going to use AI to do everything, AI all the things. And JetBrains very kindly give me AI Assistant for free because I wrote a book about IntelliJ IDEA. I will stop mentioning the book at some point, I promise. So I have a mood service here. The mood service has one method which is tested and one method I can tell it's not tested because it's an unused method. So I'm going to get IntelliJ IDEA to generate my unit tests for this method. During this demo, this is always fascinating because every single time AI Assistant does it differently. And this is the key difference between AI code generation and your IDE bog standard boilerplate code generation. When you use code generation inside IntelliJ IDEA, it's always the same. It's always predictable. When you ask AI, can you generate some tests for me? It goes, yes. But this week, we're going to do it like this. So let's see what it says. It is generating my test. It has discovered that I already have a mood service test, so that's good. It is putting them at the bottom of this test class, which is nice. It's even putting them before the end curly brace, which it doesn't always remember to do. Okay, and so we've got, it's doing them in the similar format to the existing tests, which is good. And closing off my curly brace. So it is testing a happy method, a sad and happy input. That's weird that it's doing the same test twice, but whatever, and an empty one. So I'm just going to ask it to do some more stuff. So can you please add a test for sad messages? This is where things start to get really interesting. Oh, and it did. Great. That's fascinating. Right. Now I'm going to do things like, okay, this is good. Why don't we use, all right. You can even say things like, can you please capitalize the display name? This worked earlier today. I don't know if it's going to work today. Nope. Not today.
And it didn't hear.
Yeah, it's like, la, la. Oh, it did this one. Right, fascinating. All right. Can you please use parameterized tests? Which is a good way to get it to rewrite all your tests completely incorrectly. It might work. It's been working really well recently, which is kind of sad because I kind of want to say don't use AI because it's rubbish, but sometimes it's quite good. And I've found it quite good for if you have a legacy code base. By legacy, I mean anything older than 1.5 weeks, obviously. Then you can generate your tests for existing code, including a whole bunch of boilerplate and setup and things that's often quite boring to generate. So you can use AI to create tests for existing code. And it kind of worked, but it did it for one test. Okay, fine. Let's take that and let's run it. Let's see if it works. Ah, it doesn't even compile. Oh, okay, that's fine. We can just import all of that stuff. See, I told you it was going to get caught up on there. What is that? Import static. I've already got one there. Why doesn't it work? Oh, because it added a new test. I told you the curly brace is going to get to it. All right, 2. Oh, look, and then that one fails. Well, that's kind of cool. I'm quite happy about that because it does prove my point is that if you've got legacy code, you can use AI to generate a whole bunch of particularly unit tests, but you still need to read the tests and run them, obviously, and you still need to think about them. So now, instead of reading production code, thinking about them and writing the tests myself, now I'm reading generated tests, thinking about them and maybe writing the tests myself. So there are some pros and cons, and I think sometimes it works and sometimes it doesn't. I think it's worth playing with and experimenting, but it's definitely not one of these silver bullet things. A question?
What do you think about line completion?
I like IntelliJ IDEA's full line code completion. It doesn't send your code off to the server for a start. It's all local. And it's generally pretty smart. Yes?
I've got this controversial argument that there are companies that say things like, we don't have business analysts, so we don't have anybody that's the job is explicitly design tests. So you could argue that the job that you just did there, where you police the output of the LLM, it's a bit like saying, well, I'm going to think through what we should have had after that. It's like instead of test last.
Yes, and I think I'm going to make this point later, but the point really about why is writing tests so slow? I don't know if someone's following me with a camera because I was standing here because anyway. Why does it take so long to write tests? It's definitely not the typing because it's the designing, it's the thinking, it's the reasoning. What do I expect my code to do? And the happy path is one thing, but what do I expect it to do when something weird happens? And that's very difficult to think about. It can be quite good. AI is quite good for that because AI can come up with some weird cases that you've never really thought about, but not all of them. So it's still your job to sit down and think about. This is why I love working with the testers. The testers are fantastic. They're like, have you thought about when someone passes in a null? And you're like, no one's going to do that. And the first day in production, some idiot passes null in, and you're like, oh, for God's sake. So it's the thinking about testing that takes a long time. And if you're using AI to generate tests, you still have to think about it and you still have to figure out if it's doing the right thing or not. And that's just difficult. So I asked Twitter and also Mastodon, are you using AI for testing? And a bunch of people, yes, a bunch of people said, yes, it kind of works. You do still need to think about it. It can be helpful. It's just another tool in the toolbox. It certainly doesn't replace testers or replace you in the goal of writing tests and thinking about stuff. And you do have to be aware that AI is a lying toad. I put this in as a quote for my children who are not listening to me because I always call people lying toads. So I asked ChatGPT for some quotes from women about like something, and it came up with this fantastic quote from Agatha Christie. And I looked it up, and I'm like, when did Agatha Christie say this? And she didn't. And I asked ChatGPT, when did this happen? It went, oh, I'm terribly sorry. I just got that very wrong. And it does hallucinate. So everything it says, if it says something that you agree with, you definitely need to double check it because like it just talks a lot of rubbish all the time. Right, Dave Farley said this a lot when he worked here and he was my boss, and he still says it on his continuous integration to continuous delivery YouTube channel. The problem with testing is the keyboard and writing production code. The keyboard is not the bottleneck. He used to talk about it in terms of pair programming because we did pair programming here at LMAX. It's not the typing that slows you down. It is the thinking, the reasoning. What should it do? Where should I put it? How should it behave? That is just going to take a long time. Now, whether you do that thinking when you're writing the production code, or whether you do that thinking when you write your test code first, maybe, and then merely implement the production code to pass the tests, you still need to do the thinking somewhere. So you might as well just accept that. That's our job. Another thing that can help us speed up the testing, which is something I learned here at LMAX, this whole presentation is basically an advert for LMAX. And I wrote this for DevOps Belgium last year, so nothing to do with being hosted by LMAX today. It's just that they do such great things in terms of testing here that they were doing it 15 years ago, and people still haven't caught up to the fact that this is the way that you should be working. So bring a friend, we'll help you write better tests, particularly automated tests. So this is a quote from Lisa Crispin and Janet Gregory. We recommend that developers who are good at writing efficient, maintainable code work together with the testers who are good at specifying test cases to automate tests. So when I work with Beza and DJ here, I would sit down with them and they would like say, okay, but have you thought about this? And what happens when? And it's a totally different mindset. And it's really helpful because you're like, oh, isn't it nice to think about that when you're writing the tests and the code rather than finding it way later when QA has done a whole bunch of manual testing and they come back to you 3 months later and says it doesn't work. Right? It's much better to think about it while you're writing the tests and the production code together. I was reading organizational physics and it talks about these sort of 4 personality types. And it's not set in stone and you don't sit in one square. You have a tendency to feel more strongly in one square than another. And you can also kind of move around a little bit in different situations. But I really like these kind of four ideas. We have the idea of a stabilizer, a producer, a unifier, and an innovator. And you have a tendency to find different types of roles sit more comfortably in different boxes. So for example, unifier might be like a leader type of person who brings everyone together, or sometimes your office managers are these unifiers. I would argue that writing production code and being a developer often falls in the producer and innovator area. And often producer, hard worker, fighter, short-term view, fast-paced, get stuff out. But you often also need to be an innovator. How do I fix this problem? What does the user want to do? How am I going to get over there? QA sits over here, stabilizer, organizer, and it literally says quality control. That's part of what a stabilizer is. And they have a structured approach and work at a slow. Thank you. See, fast feedback, fast fixing. Right, stabilizer. QA people need to be QA people. I know that we have different names. QA, testers, test engineers, people who sit more firmly in that space tend to be thinking about, how do I make sure that we don't make the same mistakes again and again? How do I make sure that this is done correctly? So when we're thinking about testing, either borrow someone from this space to help you with that mindset, or consider, if you're usually in the producer innovator, consider moving your mindset into this stabilizer approach. It's not about getting stuff out fast. It's not about like running. It's about stability. So there's this quote from Dorothy Parker, an American poet, and she says, creativity is a wild mind and a disciplined eye. And I know that we like to think about development as a creative art, really. It's an act of creation. It needs both of these things, the wildness and the innovation and the, you know, getting out there. But you need the disciplined eye, or you're going to lose someone a bunch of money, or your company's going to go under, or you're going to have bugs, or you're going to spend the whole time rewriting your application because you got it wrong the first time. You need both things. And that's why testing is kind of an important part of this. You need to invest the time in writing the tests to save time troubleshooting. Because if you've got a poorly written test, it's much more difficult to understand what on earth went wrong with it. By poorly written, I don't mean the test doesn't work correctly. I mean in terms of like the method names and things like that. So let's talk a bit about troubleshooting takes time. My first use case here was around when a test breaks, particularly in CI rather than your local environment, and it falls over in a heap, often your first instinct is, what is this test and what is it for? This includes two of my least favorite bad smells in tests. One, a bad method name, test increment, okay? Am I testing that it increments? Am I testing the amount it increments? Am I testing what happens when it fails to increment? What does it do? Like, yes, I'm testing perhaps an increment method, but it doesn't give me any set of expectations or how it should behave or what it's supposed to do. And assert true. Assert true is my least favorite assertion, because when assert true fails, it goes, I thought it was going to be true, but it was false. I'm like, what was false? Why did you think it was going to be true, and why isn't it passing now? So, I mean, I invented this thing.
No, I mean, an MD5 test, as in arbitrary output, doesn't know it got there.
Yes, exactly. And so, especially if you've got a big code base of automated tests from way back when a test starts to fail, particularly if it's not one you just changed, this is super unhelpful. So my particular, oh yeah, so there we go, test increment and expected. I've changed this slide from the last time I gave this presentation, and I'll tell you why in a minute. Your test needs to tell you what is expected and why, so that you have a vague understanding of what might go wrong when it fails, what might have gone wrong when it fails. Originally, I said in this slide, your test needs to help you understand if the failure is in the production code or the test code. But the more I thought about that, the more I thought that's almost impossible. That's literally the decision that a developer has to make. If the assertion fails, is it because the production code doesn't work anymore or because the test is no longer fit for purpose? But what you can do is the test can tell you what it thought was going to happen, what didn't happen, and kind of vaguely what might be the problem there. So for example, I prefer to have should in my method names, as we talked about, and I also like to use assertions like assert equals, even if the assert equals isn't going to be true equals true, because that's just not as helpful. But I like to have more clear assertions. And if you're going to use assert true or assert false, do put a message in there. I expected to get a response from the server, and I did not. Okay. My phone is ringing. Never mind. So yes, so again, this is not really about troubleshooting the test, but you have a chance of troubleshooting the test if you write them better to begin with. Okay, so I also like given, then, and when, which we talked about a bit before. This is an entirely new section of the talk, which I put in about 12 hours ago, because I'm working on a training course for Gradle, which is specifically about troubleshooting tests. Now, this training course is going to be about an hour and a half's worth of stuff just on troubleshooting tests. This is a middle section of a longer talk, which should never have been this long in the first place. And so I really want to give a bit of a brain dump on some of the ideas I'm thinking about in terms of how can we help ourselves troubleshoot tests? Like, why do they fail? Because my initial instinct was tests fail because either the test is wrong or the production code is wrong. It's that simple. But it's not that simple, because we have flaky tests. They might fail because the infrastructure isn't working. They might fail because they're running on an environment which has high load. In fact, we'll go through that as well. So I wanted to have a think about why tests fail, because I think understanding the sheer quantity of reasons why tests might fail will help us to understand why it's so hard to troubleshoot failing tests. Even though on Twitter, apparently everyone said troubleshooting tests wasn't a problem. But I wonder if it's a reason why writing tests is so difficult, because troubleshooting when they run is hard. So, like I said, horrible slides, absolute disaster. This is just brain dump of ideas. So the reason why tests fail, first set of reasons, are because of changes, obviously. We have code changes, test changes, refactoring or structure changes, data changes, infrastructure changes, load variation. I think the load variation thing is one of those things that we, especially in CI and staging environments, we often don't think about, because we're like, but the code worked before and now it doesn't work and I didn't change anything. And especially if we're following some CD principles where our environment is also versioned and we understand how our environment is changing, we can have changes in our system that we don't see. Like there's just twice as many tests running there now as there was before. So changes, that's definitely something which is going to make things break. You're going to have code issues like incorrect production logic. Exceptions are just a huge thing, and date and time. When I worked at LMAX, and I'm sure it's different now, but every time working in London is difficult because we actually work on UTC. So for 6 months of the year, we're working on UTC, right? And then daylight savings happens and half of your acceptance tests break because you forgot about time zones, like every year without fail. I work in Spain now, so we already have a time zone, which makes it a little bit easier. And the US kind of has this because they've got 30,000 time zones over there. But in London, time zones bites us twice a year, every year. It's crazy. And date and time is just difficult. On Stack Overflow, go and have a look at the number of questions around date and time. You sort of think it's easy, and it's not. It's crazy hard. And particularly because computers, they kind of have a meh idea of what time is. They're like, yeah, this is the time on this server. Completely different time on this server, which is why LMAX abstracted away the time and have a separate time service so that you can actually just get rid of time and do time travel, which is cool. So date and time, test problems, test data, tightly coupled tests, brittle tests, badly written tests, all that kind of thing, poorly understood tests. And I've got some manifests. I'm not going to go through all of these. Like I said, I just want to sheer brain dump at you the sorts of problems that we can have. Concurrency and parallelization, it's just always going to break everything all the time. If you're parallelizing your tests, you have to have written your test properly. You need to set up and tear down properly. You need isolation. You need to make sure they're not trampling all over each other. If your system is concurrent or parallelized, there's all sorts of stuff going on where you might need to wait for messages, particularly async messages, to go through various things to come back at the right place at the right time. That's just hard. If you get that right, your production code is probably also correct. So it's just a difficult thing to do. Race conditions. When we had flaky tests in LMAX, one of the very small causes of flaky tests was an actual race condition in production code, which only manifests under certain load, in certain circumstances, in certain environments. So you need tests for that kind of thing. External dependencies and services. I have a big bugbear at the moment, apart from flaky tests, of really trying to get people to think in terms of try and push your tests towards unit tests as much as possible. Because dependencies, even dependency on a jar, adding any extra dependency just adds complexity right, left, and center. Can you reach the Artifactory server? Can you reach the stub server that you've set up to do your dummy orders? As soon as you add in any kind of external API, your test just gets way more complicated and way longer and way flakier. Infrastructure issues. So this is what a lot of people tend to, developers, if they're not controlling their CI environment or their staging environment, if a test fails on one of those environments, that's your fault because you broke my infrastructure. But it does happen. Databases go away, or you've got the wrong operating system or the wrong version of Java. These things can add to a lot of frustration for developers because we didn't break it. Our test works, our code works, but the wrong database is there. Okay, and then so what we really want to be doing when we're troubleshooting a test is try and figure out where is the problem. Partly because one of the things you want to do is if it's not your problem, you want to make sure you escalate it to the right place. Is it something for platform engineering or the CI team or whatever, if it's an external team thing? Is it that the test that you wrote is rubbish? Or is it that the production code, the business logic has changed and you need to update the test code or whatever? So that's where the value comes in for you as a developer. You need to make those decisions, and that's hard. Right, so that was brain dump of that stuff. Tools for seeing more. Of course, I want to talk about tools. Let's talk a bit about Gradle's tool first. Gradle has a free tool called the build scan. Has anyone ever run a Gradle build and it goes, oh, your build failed? Do you want to run a build scan? Has anyone seen that? Has anyone thought, what is a build scan? Good, one person. Everyone else went, ignore that. So build scan allows you to publish your build for free on the scans.gradle.com. And you see the output of your build, which at first I was like, well, I can see the output of my build because I just built it. It's right here. but it's got all the other information as well. So it's not just a summary of the build, it's not just the test that failed, but it's also really useful stuff like your operating system, the number of CPU cores, number of threads, various switches which might be set in your build settings. This is really helpful for local builds because you can share it with other people and say, my build failed and it looks weird. Can you help me? Instead of having them to come to your machine and look at your machine. But it's really good for CI builds as well because you get visibility over what on earth was happening on an agent that you might not normally get visibility over. So I have to mention that, but this is free, so you can feel free to try it out. Oh yeah, and I had, sorry? Does it work with, oh yes, Build Scans works for Maven, Gradle, SBT for free. Bazel is currently paid, but probably heading towards a free service as well. But so yeah, Maven and Gradle are at a parity for features. SBT is a little bit behind, but you can use it for free. The other tools I wanted to show you for debugging are, you have remote debugging in IntelliJ IDEA, which I'm not going to go through because it's complicated to do at the best of times, but there is a good debugging tutorial on the IntelliJ IDEA reference documentation site. And what else was I going to say about that? Can't remember. But what I did want to do is show you, this was something else that one of the LMAX folks showed me years ago. If you have a stack trace from another server, for example, you can paste that into analyze stack trace. I've got it on the clipboard, so it just pasted it straight in there. And then if I analyze that, it opens it in a stack trace thing. So I can kind of just navigate directly to any of these file locations. It's kind of a stupid thing, but it's really helpful because otherwise you're going to a file and then going line 106. Of course, the caveat is you need to have the same commit locally as the commit that you've got that stack trace on, but it is very, very helpful. Okay, there we go. Right, debugging, analyze stack trace, infrastructure information required. Right, fine. I am speaking very fast, but I feel very comfortable about the fact that I'm speaking in London and you lot are used to people speaking English really fast. So aim for fast feedback and easy reproduction, which is actually exactly the same thing that Ed said. So in order to find a problem with a test, you really want to be able to run it as quickly as possible. You want to be able to debug it. You want to be able to make experiments to see if you fixed it, rerun it, and not wait 32 hours for the results, which means you really want to be building it local where possible, which is something else that Ed said. So try and get an environment where you can build your tests locally. A very wise man, this is my husband. Where's Beza? She's left now. He said, ooh, hello. Right. Yes, very wise man. He said, 99% of the time, the best way to troubleshoot a test is to rewrite it so it's smaller and faster. He does a whole bunch of stuff with Android tests, integration tests, things which need emulators. And every single time one of those tests fails, he goes, oh my God, why did I do this again? Why didn't I write this as a series of unit tests so I can run it much faster? So he almost always, his idea is just write fast tests, which you can rewrite. Also, that tiny baby in the corner there, now not paying attention. Evie? No, just too busy watching telly. Flaky tests. Flaky tests are my least favorite thing. Anyone from LMAX knows my name from the flaky test monitor. So my job, it wasn't my job, but this is a self-selected thing which I chose to do. I'd come in the mornings, I'd be in earlier than most people. I would look at our test results board and, you know, we had all these beautiful tests which were running all the time, but the board was never green. There was always failures, and that drove me crazy. I'm like, what is the point of having this beautiful test suite if it's never green? And I would go through and I would rerun all the tests because I was like, well, I don't actually know which ones of these are failing or which ones are kind of failing. So I'd rerun all of the tests, and I'd send out an email saying, these ones are definitely broken. It looks like it's been broken since this commit. You lot need to go and fix it. And then these ones are a bit flaky, so I don't know what to do about flaky tests, but they're a problem. So quite early on, I just got really irritated about what's the point in spending all this time and energy writing great tests if then they pass and fail and fail and pass, and you don't really know if they're working or not. So yes, and it means that your trust in your whole test system is eroded, because when a test fails, the first thing you think is, well, maybe it's flaky. Let's just rerun it again. Maybe it'll magically go green. And then when it does magically go green, you're like, fine, that works. No, I don't think it does. I think the important data point was the fact that it didn't work once. And what's with that? So Develocity does have flaky test detection. It has two different types of flaky test detection. One, it uses your build system retry failing tests functionality. So if you enable the JUnit to retry failing tests, those tests will be rerun. And if it failed the first time and passes in one of these later times, it gets flagged as flaky because, you know, it passed and failed during the same build run with the same data and the same code. So that's one way. And the other way it does it is cross-build flaky test detection. So it will look at multiple builds and goes, well, this build had the same code and the same setup and the same tests, and these tests passed in this build and failed in this one, which is a little bit like, oh, yes. Rerunning your failing tests to see if they pass another time is not a fix. It's a detection mechanism. It's a way to find out whether it's flaky. You don't go, well, it went green, so it's fine. I was looking at some open source project that was using Develocity, and they had reruns on, and the failing tests take about 2 minutes to run and fail. So then when you've got a really failing test and you rerun it, they had 5 retries. So a 2-minute test was being rerun 5 times. So yeah, this is not a fix. This is just a way to identify which tests are flaky. So cross-build flaky test detection, for example, AutoTrish. This is what AutoTrish used to look like about 15 years ago. That's me, because I used to have red hair. But all these tests have turned my hair gray. And so you can see here, like, these tests are failing because they were green and then they were red. And these tests are kind of like they pass, fail, pass, fail. So this is the idea of, you don't have to buy Develocity to have an idea of flaky tests. You can look across your build history to go, well, those ones fail quite a lot. Maybe they're not flaky. Maybe they're just tests which are so important that they fall over all the time with any test, any code changes. But it's still an important data point that this test regularly fails. So now you know which are your flaky tests. You can ignore those tests, right? Stop nodding. Do not ignore your flaky tests. They failed once. That is the data point, not the fact that they pass sometimes. So one of the things to do is quarantine your flaky tests. At LMAX, we used to have ignore until. Do you still have ignore until? No, blank looks. So you have put an annotation on which you say, like, ignore this test for the next 2 weeks, because I promise I'm going to fix it in the next 2 weeks. And so then it would just be ignored for the next 2 weeks. And then in 2 weeks' time, if you haven't fixed it, it'll pop back up and start failing again. It's kind of a good way to get them off the critical path. But also you do need to make time to fix the test. So you can quarantine it, you can put them in run them on a separate agent, put them over there, whatever, but just get them out of your main test suite because they're polluting your main test suite. And then really you want to fix your flaky tests because A, there's something going wrong, and B, they're slowing down your build because you're probably rerunning them anyway. So Dave Farley, who used to be my boss when I was here, has excellent video on the 5 causes of test intermittency, which I've kind of summarized here. But have a look at the video. It's really good. So once you get a better understanding of the 5 causes of test intermittency, you can start looking at, you know, which one of these is likely to be the cause of this particular test failing. Number 5 is system behavior. One of the things which can cause flaky tests is that your production code is broken. So you do need to fix the flaky tests because it's not just a test thing or an infrastructure thing or you don't have enough resources. It might be, as we found, a race condition in your production code. That's where Blazer is. Hello. Part number 3, running tests takes time. We're going to run out of time. Running tests takes time. So this is really where all right, Maven users, how do you speed up your tests? I really hope what they meant was sometimes I run it with skip tests. But again, like, you spent all this time writing tests and now you're not even running them. Like, what is the point? Okay, one of the ways to speed up tests is to use a build cache. This is something we do have for Develocity, but it's something that you can get from, there are free, Gradle has a free build cache, Maven does have a free build cache, and also you can kind of grow your own and stuff. But Develocity has local and remote build cache. They're very useful for multi-module projects. For example, if you have the idea of like, it's got like a core module, some service hanging off that, some web app hanging off that, some API hanging off the core. Often, particularly with Maven, if you want to rerun the build, you have to redo all of those things, including rerunning all of your tests, all your test compilation, everything. But if you have a build cache, you change something on the export API, you don't need to rebuild everything else because you don't change everything else. So you just need to rebuild and rerun everything on the export API. Similarly, if you change a module's implementation, you need to recompile it. You don't necessarily need to recompile your tests because nothing there changed. You do need to rerun your tests and your check style or your whatever replaced check style recently. What's it called? Never mind, doesn't matter. So then you don't need to redo everything. You just have to rerun the tests which are relevant. Worst case is if you change something in the core, then you need to rerun all of your tests. But the idea of a build cache is for some percentage of your changes, you don't need to rerun all of your tests. You only need to rerun the ones which are affected by that change. What's really interesting is when you use it as a remote build cache, because your commits your tests are being run all the time in CI, right? Hopefully. Your code is being compiled, run, check styled, static analyzed in CI. The results of that can be added to the remote cache. And then when you run the same code locally, you can get the build cache results. You can get the compiled code. You can get the test results. You might not need to recompile everything when you get a commit from CI, because CI already ran that commit. So you just get the results, and it's much, much faster. So Develocity has a remote build cache, and we have a bunch of, for example, big bank customers who are getting great use from this. If you've got big multi-module systems, it can really speed up your builds. Obviously, you want to run your tests in parallel. If you are using something like Gradle or even Maven, you can run your tests in parallel. I have a video of this because this no longer works as a live demo because like live demos suck. But you can see all of my CPU cores are being utilized and I'm running all the tests on various different cores. And that's what parallelism is good for. So you can kind of get your nice throughput through the different cores. CI, generally, I hope you're running your tests in parallel, because what's the point of having CI and all these lovely agents if you're just running everything on one agent? So this is, for example, Kotlin has a bunch of different agents running different types of tests. Often what you do is you manually partition your tests to run on these different agents. That's not necessarily ideal. What you kind of want to do is you want to say, I'm going to run 30,000 tests. I have 20 agents. Go. And so that's what test distribution does. Test distribution takes your tests, whether it's on a local build or CI, a random number of test distribution agents, and just farms your tests out over those agents, which, incidentally, LMAX was doing years ago with Romero. And Develocity has this built in, and I haven't seen anyone else doing this. And it's totally doable with JUnit. You just get the list of tests and farm it out over the various agents. And it works in CI and locally, and why not? Especially if you've got a whole bunch of big, powerful machines like they have here. When you run it locally, you don't have to run all your tests locally. You can farm them out over the machines which aren't really doing anything and get huge parallelization. Netflix, for example, uses Develocity's parallelization, test distribution. And so they, generally speaking, obviously, as you double the number of executors, you halve the amount of execution time because you're farming it out of the more agents. Netflix reduced their build time from over an hour to under 5 minutes by using test distribution. Of course, you do need to be able to parallelize your tests to some extent, but if you're going to use them on different agents, different physical agents, you don't have as much of a problem with test data running over each other. Of course, we're going to use AI because it's 2024 and everyone's talking about AI. There is a thing, Meta did a white paper on predictive test selection. What they wanted to know was, they've got this huge mono repo, and they're like, every time I make a change, I shouldn't have to run all of my tests. I should be able to figure out which subset of tests I need to run to make sure I haven't broken something horribly. And in Meta's white paper, they found that for their mono repo, generally speaking, they only needed to run about 30% of their tests for most changes. So they cannot run 70% of their tests. So we took, Develocity, we took the algorithm they were using, and it's a straightforward machine learning algorithm which you can inspect. It's not one of these weird LLMs which comes up with answers out of its arsehole. It actually uses mathematical modeling to figure out, like, when you change these lines of code, it's these tests which are the ones which often fail or give us some useful results. So it can tell you why it picked those tests and why it ran them, or why it didn't pick these tests. And you can also tune it in terms of, I want more reliability, so pick more tests, but it will take more time, or I want more speed, so pick fewer tests, and I know that sometimes some tests won't get run when maybe I wanted them to run. The key about predictive test selection is it's really helpful for local builds, of course, because what you want to do is get a sanity check that you didn't break anything horrible. You don't want to run it on your production branch, right? You really want to run all your tests on the release branch. So it's only suitable for certain subsets of branches. But what if that's 90% of the branches that you run tests on? You can save a whole bunch of time. And we found that, right, so the Meta paper said the test selection procedure selects fewer than a third of the tests. Our customers, so this is build time. The blue bar is not testing time, so like builds and creating artifacts, so ignore that. The red is the amount of time spent testing, and the orange, yellow, I'm colorblind, I don't know, is the amount of time it would have spent testing if it wasn't using predictive test selection. So those are all the tests that weren't run. With our customers, we generally find they can skip running 50% of their tests, sometimes more, sometimes less. But you can imagine the build time savings by not running 50% of your tests, because you don't need to, because they're not going to tell you anything. So predictive test selection is a really interesting technology there. And I don't know if you want to talk too much about this, but when I gave this presentation, when I gave the DPE talk at the LJC last year, which some of you were at, one of the guys said, I just have a lot of tests. That's why it takes a long time to run the tests. So I asked Twitter, how do you fix this problem? Angie Jones, who knows a bit about testing, she said, yes, delete tests. It's really, you can't just keep adding tests. It's important to also prune the tests as you go. And a bunch of other people on Twitter said, yes, once you get to become a mature organization which regularly writes automated tests, having a lot of tests, some of them may be duplicates, does become a problem. And there are potentially different ways that you could look for where the duplication is. You can look for like coverage, and you can use mutation testing, and you can look for things like every time this test fails, these 6 tests also fail. So you can look for patterns in that kind of thing. But it is quite difficult to identify which tests are no longer needed. So it is a challenge. And I was talking to our CEO about this. I was like, maybe we could use some machine learning to kind of do something like this, look for patterns and figure out which tests often fail together, for example. So it is important to potentially delete tests, but it's not necessarily about the number of tests that's the problem. Because if you've got 1 million unit tests that are single class unit tests, they don't take very long to run at all. So it's not necessarily a number of tests that's the problem. It can be the fact that you have 30,000 integration end-to-end tests, which have to start up services for every individual test method. So I work on an open source project. I lurk on an open source project where it's a MongoDB project. And originally, the test and build time was 90 seconds. And the dependency was, you have to physically start up a MongoDB instance on your local machine, run everything, and then shut everything down. And then what they did is they sensibly decided test containers. That's the way forward. We're going to use test containers. But the way that the tests had been written a long time ago meant that the database wasn't properly cleaned up. So the easiest way to do that was start up a new instance for every single method, test method. Not every single test case, every single test method. So now the test time was 90 seconds, is now 5.5 minutes. Okay, so things that make a test slow is not the number of tests, it's how you're testing, particularly external dependencies, integration, anything which reaches outside of a class slows you down. So The key about if your tests if you tests take a long time, of course, feel free to call our sales folks and ask for test distribution and PTS. But you want to focus on the worst performing tests. And you can look at your longest performing test and say, why does this test take 5 freaking minutes? Is there something I can do about it? For example, you want to be pushing them down the testing pyramid as much as possible. Yes, there is value in end-to-end service integration, UI, whatever you want to call them, acceptance tests or whatever. You will need tests which test the whole thing. But by default, every single test in your system should not be spinning up servers or using Docker or using test containers, because there's a whole bunch of stuff you can test at the unit level. If you're testing validation, you don't want to bring up a whole server to test, will it accept a username with a $sign in? You can test that on the unit level. So you really want to push stuff down as much as possible. Which was something else, Kelsey Hightower said this as well. He was saying, like, by all means, start by running everything together and do a whole bunch of end-to-end tests. As soon as it gets clunky and uncomfortable, you want to be breaking that stuff out and trying to remove the dependencies as much as possible. Another place where tests get really slow is expensive setup and teardown. Like I was sort of saying, the test containers thing. Do you even need a MongoDB database if, in fact, you know what the schema should look like and you can just do a string comparison with the JSON, which is being sent to the back end? Why do you need to start this up and tear it down? So expensive setup and teardown is often a place where, you know, tests really get slow, because especially on the, the setup method, which gets run for every individual test method. And there's often stuff in there you just don't need. And event time travel. That's easy. LMAX did it. Time travel was a really good way of testing things like end of day things. So you don't want to test to wait to 5 p.m. to run, because that's really slow. So if you can stub out the time or create a time service, then your tests can say, wind me forward to the end of day and make sure that you fire all the events.
Making time deterministic in the scope of the test.
Yes, in the scope of the test, time is deterministic. So you, correct me if I'm wrong, but there is a blog on this later on. So all the resources for this are there's a QR code at the end. But yes, instead of being reliant on an individual machine's time clock, there's a time service. So you can take that away and put your own time service there. Yes?
Jailbreak late time, there is an implementation of the clock you can do this with.
Yes.
Strongly recommend injecting clocks into your things at clock time.
Exactly. Anything which involves time, you just want a layer of abstraction there. You don't want to be looking at the CPU time, because it's just not going to work. Respect your test code. No. Why would you treat your test code with the same respect that you treat your production code? Well, because, you know, it tests your production code. It's important. So all the things which are important for production code are equally important, or possibly more important, for test code. You still need solid and dry and descriptive naming and modularization and reusability, and you still need to refactor and delete and like take care of your test code. And there is tension between some of these ideals. So, for example, if you go for like a lot of separation, for example, you could end up with maybe a lot of expensive setup and teardown, because everything is like so independent. So you need to find the sweet spot there between the right design and the performance of your tests as well. And there will be compromises, because that's what we do as software engineers. We're all looking at where is the it depends and what is the right answer for this particular use case. Right, in summary, automate as much as possible. This is the principle behind DPE, Developer Productivity Engineering. It's all about, the reason why it's Developer Productivity Engineering is it's engineering solutions to help us with our productivity. So your tests need to be automated. They need to be run in an automated way. You need to use automation to identify your flaky tests. You should be tracking build times, test times. You should have analytics on what's going on there, because otherwise you can't do anything. You can't troubleshoot your tests or figure out, is your performance getting better or worse? And there are solutions designed exactly for this problem. So Develocity isn't the only one. Feel free to call our sales folks, but there are solutions out there, so you don't have to reinvent things. And I really want people to take this away, because it does take a long time to write tests, because there's thinking involved, and thinking takes time, should take time. So it is difficult to write good tests, but it's also difficult to write good production code. And you need to spend that thinking time somewhere. It's not double. You're not going to think about it once during testing and once during writing the production code. You just need to do it once. You might as well write the production code and the test code at the same time. Yes, and so your best and wisest refuge from all your troubles is in your science. So use engineering approaches, use science, do the analytics, look at the numbers, record stuff, and figure out what your patterns are. This is an engineering problem at the end of the day. Great. So all of the links, there's a page. This is a link to a page which has all the links for things like predictive test selection, the blogs I've mentioned from LMAX, most of which was there before I even came and gave this here on the LMAX site. And then if you are interested in winning a copy of Getting to Know IntelliJ IDEA, you have about 13 minutes to fill in this form, and I will pick a winner and I will physically give you a copy of the book before they kick us out at 9 o'clock. Thank you very much. If you have any questions, I guess just come up to me and ask them. Otherwise, feel free to go. No, or I suppose you could ask questions while you're filling out your thing to win the thing. Any questions?
Are you okay for me to throw this at you?
Can you hear me on this? I was going to ask a question about one of the things that I often hit against when using Gradle for multi-module build, particularly large ones. Like in our repo, we've got, I think it's like 800, 900 like modules within there. Identifying links between modules that don't need to be there because someone's listed a dependency between modules that isn't actually there is a big slowdown, because you end up rebuilding quite a lot, particularly if you hit like a hot path of dependencies. Is there any tooling that's available other than like rolling around to try and identify where those, unused links are?
That's a really good question. So the build scan, oh my God, I just kicked my thing across the thing. The build scan will show you, I have got a build scan somewhere.
Yeah, it's quite useful for showing what ran on a particular one, but actually trying to identify whether you needed to run that in the first place.
Yeah, exactly. So it'll let you see what your dependencies are. And oh, I know who I was talking to about this, Azul. So Azul, the JVM vendor, has a way of identifying dead code paths, like dependencies that you don't need. Including in production. So it'll also show you the code that's running in production, because obviously they can do it on their JVM. The code that's in production, like this bits of code just never gets run. Okay. So that's one thing. But yeah, it's a difficult problem. I haven't really seen anything which will say you don't need this dependency.
Yeah, I mean, I've been playing around with something myself, but I mean, it requires knowing quite a bit of Java ASM, and there's always some kind of dependency rule that you didn't think about that's not like easily codified somewhere.
Yeah, the only thing I've seen is Azul's tool, because it uses your real code in production and tells you what is never used.
Yeah, thanks.
Just delete it.
Completely loading up, but I've been playing with Gradle a lot, and it's very good at trimming. I don't know if you're able to plug into that when it does it, but I don't know.
I might look into that.
It's very much JVM level, isn't it? Really,
Yeah,
I think that's the thing.
It just basically, anyway.
Oh yeah, I'll chat to it. Like I said, I've been playing around with using Java ASM to do it, but you have to know the compile time dependency resolution that the JVM uses to be able to codify that.
Yeah.
I think
it's doing stuff up. It's basically doing trimming that JS tools does, but it does when it's building a native XC. So it knows somehow how to, just find out the code you never, because instead trying to make the XC so small that it can run faster and all that.
Yeah. It is a difficult problem. I don't think there's anything. I mean, some of the IntelliJ tools will tell you if certain things aren't called, but it won't always do a good job with external dependencies, because it can't always trace those code paths.
Yeah. Well, to your point about Gradle doing it, I did read at one point try and read through the source code for Java C, because that technically does contain the rules, but it's embedded in the really complicated logic of like actually trying to parse the code rather than actually codified somewhere that you can
I don't wanna
actually.
hate this, but that's why I said maybe there's a way to plug in.
Yeah.
Graph teams on Slack and they're very fast. Anyway.
I'll try that. To your question of brute forcing it, I did write a previous implementation that I did run a build where it removed a dependency, tried to rerun everything, failed, and if it didn't fail, delete it. But it did take like 24 hours to prune the graph, which is quite expensive, and probably quite a lot of compute power.
We are all that sort of that, they just pass through rather than doing their set.
You what, sorry?
So we have a tool that sort of does the unused dependencies. We just pass the bottom rule. So ASM won't give you that, but it can just, it's fairly easy to pass it.
So it just looks for all the classes that are referenced by a given class, and it can do that across the jar file, and then it just maps out what is and isn't used.
Yes, complexity of all the things you don't expect is in like looking through the type hierarchy and things like that. That's kind of quite tricky.
Yeah,
Stuff that's not important.
it is a bit blunt, but it's more heuristic than exact. But
More questions?
Anyone?
Okay, well, it looks like everyone's keen to go home. Whoa, deadly. All right, well, great. Thank you. What have we? Are we going to be kicked out in like now or?
Yeah, we only have 5-10 minutes because we have overrun a bit, but there is a pub around the corner that we're all going to go to. So yeah, if everyone wants to follow, if you find out, we go to the garden pub or the garden bar. They call themselves a bar, but it's a pub. Yeah, so it's just next to Lassiter Road Tube, but if you follow someone with an LMAX t-shirt or who clearly works at LMAX, because not everyone's wearing them, they know the way, but it's not far, it's just less than 5 minutes.
Some feedback for you,
Yeah.
just because I have been away from Gradle for a very long time, and then someone lent the project that needed working on, and I ended up with a lot of build problems, and it kept spitting out a lot of stuff, and I did the scan thing. But you know what? The LLMs, they are very good at explaining at high level what the problem is or how build can be improved and all of that. So if you want to add that as a feature too.
It's a good point actually, and I've used
Summarize this in tired they speak to me.
yeah. I've used the JetBrains AI assistant for that as well, because you can right click on stuff and say, tell me what this is.
Yeah.
And it does a really good job.
Definitely go about it.
Okay.
Oh, generative AI is much better with stuff that already exists on
Yeah.
something it's
Yeah, exactly. Does this apply? Just, I'm too tired. Tell me what this means, and it does really well.
All right, great. Thank you very much.